Hi, this video is going to talk about ratio, which is our 7th topic, and it's chapter 5 in our textbooks. In this unit, we'll be looking to simplify ratios involving same or different units, simplify ratios involving two or more than two quantities, divide a quantity into a given ratio, find the map ratio given the distance represented on a map, use the map ratio to find the distance between 2 points, state when two quantities are in direct proportion, and use the unitary method to calculate unknown quantities. So ratios are used in everyday life. They can be used in many situations, for example, to adjust the recipe for a certain number of people, or they can be used in maps to show the scale. 3 to 4 is an example of how we write a ratio, and they can be used to describe two different items or amounts. Ratios show how quantities or amounts are divided up, and usually the quantity of one thing is compared to something else. Ratios can also have many parts, so we could have it in the form of 1 to 3 to 5, or 1 to 4 to 5 to 6. And the order of a ratio is really important as it refers to each specific quantity. If you wanted to make some squash or diluting juice, I could use orange to water ratio 1 to 4. This means that we've got 1 part of orange and 4 parts of water. 7.1 Simplifying ratios. Simplifying a ratio is the same idea as writing a fraction in its lowest terms. So we try and divide each part by a common divisor. So we look for the highest common factor for all the numbers and divide each part by the ratio, or each part of the ratio by it. If a ratio involves different units, for instance, if it was in kilograms and grams, or centimeters and meters, we must convert them all into the same units first of all. A fully simplified ratio should not contain any units, and it should not contain any decimals either. So in the same way, if we had a fraction of 5 over 8.3, we don't like that. That looks grotesque and hideous. We'd need to write that as 50 over 83, so multiplying top and bottom by 10. In the same way, we wouldn't leave a fraction as 1 to 1.2 because we don't like that. That would be, well, we'll see later on, but that'll be 10 to 12 or 5 to 6. So we've multiplied both sides by 10 and then divided by 2, but we'll get into that in a minute or two. So we've got 3 examples then. The first one, simplify £15 to £9. So they both have the same units, so they're both in pounds, so we don't need to do any converting there. So we're going to write it as just 15 to 9. So we don't need any units, so we can just leave that. The highest common factor between each of those, well, they each share a factor of 3, so we can divide both by 3, and we get 5 to 3. So 15 divided by 3 is 5, 9 divided by 3 is 3, and 5 and 3 don't share any factors, so we leave it as 5 to 3. And remember, we don't need the pounds because we don't need units. Example 2, simplify 8 kilograms to 36 kilograms. Again, we can see the units are the same. So I'm going to rewrite the ratio without the units. So it's going to be 8 to 36. They each can be divided by 4. 8 divided by 4 gives us 2. 36 divided by 2 is 9. So then the ratio simplifies to 2 to 9. So 2 to 9 don't share any other factors other than 1. So that's it in its simplest form. And then the last one, example 3, or the last one for now, is simplify 200 grams to 1 kilogram. And here we can see that actually they have different units. And it's easier to change a kilogram into a gram. It's going to leave it as a much nicer number. So we're going to do that first of all, and that's going to be 200 grams to 1,000 grams. Remember, there's a kilo. The prefix means 1,000. So that's 200 grams to 1,000 grams. We can then rewrite it without the units. So 200 to 1,000. And we can see that they share a common factor of 10. So we could divide by 10 and we'd get 20 to 100. Again, they share a common factor of 10, so we could divide by 10 and we'll get 2 to 10. And now they're both even numbers, so we could divide by 2. Well, not now they're even numbers, they were always even numbers, but anyway, we can divide by 2 to get 1 to 5. And that's it simplified. Those of you might have spotted at the start, we could have divided both by 200, and that would have ended up with 1 to 5 as well. But it's always okay to split it up in different terms as you see fit. So decimals and fractions. A ratio is not considered to be simplified if it has any decimals or fractions in it. We must therefore begin by getting rid of these. So what we mean by that is if we had a fraction, or if we had a ratio of 3/4 to 1.2, that's no good. We don't like that, and we're going to have to do something with that. To get rid of a fraction, we multiply through by the common denominator of the fractions. Remember to multiply all parts of the ratio. So in this example, we'd multiply through by 4 to get rid of the fraction there. So and we would get 3 to 4.8. So we've multiplied 3/4 by 4 to get 3, and 1.2 by 4 to get 4.8. So that's how we'd get rid of the fractions. To get rid of a decimal, we multiply by 10, 100, 1,000, etc., depending on how many decimal places are. So in the example we've got 1 decimal place. We'll multiply both by 10, and we'll get 30 to 48. When you get rid of the fractions or decimals, you now need to check whether the ratio can be simplified. So 30 to 48, we can see they're both even. So we could divide by 2 to get 15 to 24. 15 and 24 divisible by 3, so we could divide by 3 to get 5 to 8. And that would be it in its simplest form. So 3/4 is no good, 1.2 is no good, so we need to do a couple of steps to try and make life a little bit simpler. So example 4, simplify 10 to 15 to 20. So this is an example where there aren't any fractions or any decimals, but we've got 3 ratios here. And we look and see what's common between 10, 15 and 20. And what we can see is that they all are divisible by 5. So if you divide each by 5, so 10 divided by 5 is 2, 15 divided by 5 is 3, and 20 divided by 5 is 4. And although we could divide the 2 and the 4 by 2, we can't divide 3 by 2, so 2 to 3 to 4 and is in its simplest form. If we've 0.6 to 2, what we need to do is multiply both sides by 10. So 0.6 times 10 is 6, and 2 times 10 is 20. So we've now got rid of the decimal, but we need to check and see whether this can be simplified, and hopefully we can see that both 6 and 20 are divisible by 2. And that will leave 3 to 10, and that can't be simplified any further. So 3 to 10 is our answer there. In 2/5 to 3, what we need to do is we multiply by the denominator. So if we multiply through by 5, what we get is 2 to 15. And then 2 to 15 can't be simplified. Now just to explain what we're doing there in a little bit more detail, if we've got 2/5, what we're really doing is we're multiplying it by 5, and we're multiplying 3 by 5. So similar to equations, what we need to do is multiply both sides by the same thing. So here we're multiplying both by 5. Now on the left, here we've got 2/5 multiplied by 5, a fraction multiplied by a whole number. To do that, we'll put the whole number over 1, and we'll see where we can cancel. We can see the 5s can be cancelled to leave 1 and 1. And then we multiply across the tops, so 2 times 1 is 2, over 1 times 1 is 1, 2 over 1 is just 2. So whenever you multiply a fraction by its denominator, we're just left with the numerator. And then 3 times 5, hopefully I don't need to explain how that gets to 15. Example 7, for every 8 red cars are sold by a garage, they sell 6 silver cars and 4 blue cars. Write down the ratio of the number of red to silver to blue cars in its simplest form. So it's really important that we keep the order the same. So what it's saying is red to silver to blue. And we're said that for every 8 red cars, that's going to be 8 red cars, they sell 6 silver and 4 blue. And what we can see, 8, 6 and 4 are all even numbers, so we can divide each term by 2, and we get 4 to 3 to 2. So that's it simplified. And now what you should be able to do is exercise 5b if you're working with the old books on page 90, or exercise 5a if you're working with the new books.